This is a recording for those who missed class on Wednesday on section 2.3. You need, this will be a good one to watch before you do the activity 1.1.1, which is a PhET simulation on motion, dealing with velocity and time graphs and as well as position time graphs. So in this lesson, we've already talked about displacement in the other video. Now we're talking about time and speed or velocity. Time is, at the standard unit for time in the metric system, the SI system, is a second. And so be careful on problems if you're not given time in seconds. If you're given it in minutes or hours, make sure the conversion you're doing is asking you to deal with derived formulas that have the same unit. You always want to be careful of that. But seconds is the standard unit. Here you have equation 2.4 says that the change in time equals the final time minus the t naught, or the initial time. At the bottom it talks about this being the elapsed time, or the time between the two events. And generally that's going to be the final time minus the initial time, which will be t. The average velocity in equation 2.5 there is going to be your change in position, x, divided by your change in time. Notice the v has a bar across the top that indicates it's an average velocity. So your displacement, or your change in position, divided by your time. And that's what we, equation 2.6, they lower it to, or rewrite it as average velocity equals delta x over t, because we're dealing with a time that has elapsed during the exercise. The example they give us here for 2.7 is they say here that an airplane passenger took 5 seconds to move -4 meters. And what was the average velocity? Well, if they start at the front of the plane and we designate the front of the plane as positive, then they're walking backwards. So the final velocity, displacement would be -4 meters. The initial is 0, so -4 minus 0 is -4 divided by 5 seconds would give you -0.8 meters per second. That does not mean that you're slowing down. That just simply means that the person is walking towards the negative position, therefore has a negative velocity. As we scroll down here, we see speed. Speed is similar to velocity in that its magnitude is the distance over time, or displacement over time. Distance over time, but it doesn't care about the direction. It is simply magnitude. And so that distinguishes speed from velocity. Down here, I'm going to spend most time on these three graphs as we try to model what it means to have motion in these different graphs. So the position time graph here in this first illustration, all three of these show the same motion from a different perspective. And I like the way they do that, and it, I think, makes it more clear. Notice in this first one, position time. So it's position versus time. It is position is a function of the time, and the position is the dependent variable on the y-axis. Time is the independent variable on the x-axis. So the position depends upon how much time passes by, and that's important to understand those relationships. Now we're talking about kilometers for the position, and we're talking about time for the hours for the time. So as at 0.1 hours, the position is about 1 kilometer. At 0.2 hours, it's about 2 kilometers. So at about 2.5, at 0.25 hours, a quarter of an hour, I'm assuming plane has traveled 3 kilometers, and that is expressed by that point there at the 3 and the 0.25. Notice that the line going up has a consistent, it's a straight line. It has a slope. That slope is equivalent to the speed of the object. And notice it's a constant speed for that whole time. But then suddenly at the 0.25 mark, the motion changes. And now instead of moving away from the frame of reference position, the 0 mark, it's now coming towards the 0 mark. And so now it's coming back, notice, at the same slope, just inverted. So it's a negative slope of what it had before. And so now the object is coming back towards the 0 position. And at the half-hour mark, the 0.5, it reaches that 0 where it started from. It basically ended up where it started. So that's a position time graph. This second one is a velocity time graph of the same motion. Now we have velocity of kilometers per hour on the y-axis, and we have time in hours on the x-axis. And notice that the 0 is in the middle of the graph on the vertical position. And so the first, at the beginning of the object's motion, it's got a speed of 12 kilometers per hour, represented by that horizontal line at the 12. It's going for, again, that 0.25 hours, which is a quarter of an hour, and then suddenly it drops straight down. What that indicates is that it changed direction, because now the speed is still 12, but now it's negative 12 because they're going back in the opposite direction. So just like we explained on the first one, at the 0.25 hour, it changed directions. And that's what that pyramid, that triangle looks like in the distance position time graph. But now that's the same representation in the velocity time graph, in that you have the 12 going across in the positive, and then suddenly it drops down to negative 12 at the bottom, and that indicates that they've changed direction and are going in the opposite direction at the same speed, just in opposite direction. The last one is a speed versus time, and now we have speed as our dependent variable, time as our independent, and you notice that the speed graph does not have any indication of the direction. It just indicates that for the first 0.25 hours, the object went 12 kilometers per hour, and that after that it continued to go 12 kilometers per hour. It has nothing to do with direction, just indicating its overall speed. Use this information to help you with your PhET activity simulation for 1.1.1.